So this is pre-calculus. The entire unit is called limits. And although I will teach you through these lessons the start of limits, very much like trigonometry, limits never end. So I am just touching the beginning of this. The reference for this particular sheet, which is in your workbook, is page 102. So I've got some questions here that apply to this particular function. It is a function. It does pass the vertical line test because if you notice very, very carefully, this is actually supposed to be an open circle. Then it travels along, and that's a dot, which means it actually lands there. And then this is an open circle, so you do not arrive at 2 points at the same time. Then there's a line that takes you to this open circle, and then you pop up here and you get a dot, and you keep going until you get to this dot. So this is called a piecewise function, sort of like a rational function in that it's one function made up of many, many parts, in this case 3. So what I want to do, and I wish I chose to fix this sheet, but I did not. What I want to do is I want to clump my work. So I'm not going to do it in the order A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, oh, just to N. We are going to do them in clumps. So the first ones that I'm going to deal with are all the ones that have everything to do with x approaching or equaling -1. So this says x approaches -1. I will explain this in a second. So I'm going to circle that in red. This also says x approaches -1. That's a little positive sign instead. So I'm going to circle that. This is x approaches -1. So I'm going to do that. And then if there's another one that has -1, nope. So those are the ones we're going to take care of first of all. That means that I have to focus all my energy on x equals -1, which is this area of the graph, and I didn't go over it entirely in yellow so you can see those things, because if I go over it, it erases kind of the information. So what I want you to know is that this little negative sign means focus on the left. So we need to know where the left side of -1 is and the right side of -1. And again, I mean left side of x equals -1 and right side of x equals -1. So what you have to do is you have to imagine that this part doesn't even exist. And hopefully I will explain this well enough so that you realize that this is just graph reading. The notation, the way you write it down, is probably more complicated than it needs to be at the start, but will become better and better as it goes along. And if you have any problems, please ask me. So with this question, we need to figure out where the graph bumps into x equals -1. So the graph travels along, travels along, travels along, travels along, and ends right there at y equals 0. So this answer is 0. This little negative or positive sign, that means from the right side. So that means I have to erase all the work here in green. Let's find an easier way to take care of this. And this time you ignore all of the left side information. And you travel along until you bump into x equals -1, and we get to that spot there, which has a y value of -2. Now there's something to be said about this, and that is when we went in from the left side, it ended in a dot, and when we come in from the right side, we end up in an open circle. Yet you still have an answer. So what limits actually mean is as x approaches -1 from the left-hand side, where are you getting close to? And you're getting close to y equals 0. Actually, in this case, you're landing on it. As opposed to this one, which is the limit as x approaches negative 1 from the right side, where you are approaching but not necessarily equaling to negative 2. So a little note here is that if you are talking about limits, you can have an answer that is like this, or you can have an answer that is like that. So let me just write down what this notation means. So this is limit as x approaches negative 1 from the negative side of f at x. So limit as x approaches negative 1 from the negative or left side of f at x versus the limit as x approaches negative 1 from the right side of f at x, or g at x, or whatever else I could give you. So this indicates left side, and this indicates right side. And again, your answer could be a closed dot or an open circle at whatever this x value is approaching. So there's one last question about negative 1. And with this case, I took off whether you're supposed to look on the left or whether you're supposed to look on the right. And I want you to know that this answer is that the limit does not exist. Welcome to Mean Girls. So the limit does not exist because you can't have two different answers from the left and the right and expect an overall answer to actually exist. So because one of the answers, the left one, was 0, and the other answer, the right one, was negative 2, you don't have an answer here. If these two are the same, you would just steal your answer and plunk it there. So what I need to do now is I need to erase all this information, every single bit of it, and we need to find another clump of information. So this time, this one's got x approaches 1 from the negative side. This one is x approaches 1 from the positive side. This is x approaches 1 over all. And this says f is actually 1. Sorry, f at x is actually 1. So that means I need to focus all my attention along this strip, which is where x equals 1. You can probably barely see that. You also need to determine your right side and your left side, so you need a good handle on direction. And then we can try to answer these questions. So from the left side, we don't look at any of this stuff. From the left side, we travel along, we travel along, we travel along, and we bump in right there. And I realize it doesn't have a dot or an open circle, but there is a value there. It's a tiny dot so that you have a bunch of little dots that make this line. So it's actually this situation, and that has a y value of 0. So now I need to reverse my thinking. And I need to not worry about the left-hand side. I need to come in and eventually follow my curve until we get to x equals 1 from the right-hand side. And that just happens to be in the same spot, and it's a 0. So here's left, here's right. They both have the same answer. So when I ask you for overall and don't specify left and right, you actually have an answer this time. Because these were the same, you have an answer. Because these were different, you don't have an answer. Now, possibly one of the hardest questions on this page is questions like H. And although this is very important, that limits give you answers whether it's a dot or a circle, if I give you an f at x and I specify an x, you're only allowed to talk about the dot. So this is saying, where is the dot at x equals 1? And the answer to that is 0. If you travel along and look at x equals 1, there's a tiny little dot there, so tiny because you've got a bunch of other little dots that end up making this line. And I can move that out and erase all this. So now we need to find another clump of information. So this time I'm going looking for, there's a -3, but I don't see any other -3s. Here's a 2. Here's a 2. Here's a 2. And here's a 2. And all of them are x approaches or x equals 2. So we're going to do all these purple ones next. That means I need to shift my thinking to that strip right along there. First question is about the left-hand side. So here's my left, here's my right. I need to travel in, I need to travel in. This one doesn't even come close to over here. So you keep going, you keep going, keep going, and it doesn't matter if it's an open circle or a closed circle, that's your answer. So that's x equals 2, y equals 1 up. So you almost get there. So this is saying as x gets to 2 or almost gets to 2, where are you getting to with the y? This one says focus on the right side. So you travel in, you travel in, you travel in, and you get to there. You actually get there, not that it matters with limits. And so your answer is 3. And then when I take away the direction, when I take away the fact that you could look on the left or right side of x equals 2, you have to check these answers, or at least think about the answers to those, and then give a DNE or recopy. So the last question about 2, and I just want to erase all this to make it clear, even though I probably should leave the yellow. The last question is what happens, like where do you actually get to at 2? Where's the dot? And it's not there. It's here. And that is 3 units high. So you answer with 3. So limits are you get to it or almost get to it, and f at x is where the heck is the dot? So now let's look at the questions we have left, which are kind of don't fit into any category. So these two fit into a category because it's about x equals 3 and x equals 3. Technically, x approaches 3 and x equals 3. So I can put my little strip of yellow down here. And this says focus on the left, which is a really good thing because there's no information over here on the right. So if I look at this, nothing to do with over here. Nothing to do with over here. This one comes in and actually lands there. That is x equals 3 and y equals 0. And then if you take a look, because that's a dot, this is saying where is the dot at 3? And we can answer, oh, it's 0. So I'm going to erase that information and do the very last question, which is actually the first question. And the first question was asking us about x approaching -3. So here it is. And we want to know from the right side, which is a good thing, because there is no left side. And this is traveling in, traveling in, traveling in, and almost getting to there, which is 1 up in the air. So I'm going to make an extra question, N-O. I'm going to ask you, where is the dot at -3? So let's erase the clutter and focus on -3. And there is no dot. It's an empty circle. So you can have does not exist answers for limits, and you can have does not exist answers for function answers. So both of them. So the next thing I'd like to uncover is this, which is actually the title of the note, not necessarily the last unit stuff. Limits are pre-calculus, so if you're going on to calculus, then you need to cover this again. It won't go away. completely if you're going on past high school calculus, but it is the beginning of the calculus course in calculus and vectors. So a limit is technically a boundary that may not be passed. So that means it could be the open circle, or it could be the dot. It's the exact value. The limiting value of a function is the numerical value that the function will have if the limit is reached. All those words mean is that I am looking for a y value, because in every single case I give you an x value. So your job is to give me kind of the response. So I'm going to take a little hand cramp break. We are coming back to do this question. I'm not actually so sure that it is on page 102. It could be the bottom of 102. It could be 103. I'm not 100% sure. But we're going to take care of, I don't know if it's this question. Oh, let's do this one. It's a bit bulkier. So this is the question we'll come back to. You will need some graph paper for it. Even though we like to sketch in this course, it's graph paper time. So I'm going to pause this for a moment and come back at you. Okay, time for the graphing. So the reason I took so long with my break was because I forgot I needed graph paper, even after warning you. So now let's talk about these graphs. And there's a reason I'm doing this question versus question 2. Part of the reason is because it's got 3 functions that make an entire function, as opposed to 2. I hope that you recognize that this particular question has a parabola and a line. Parabola because it's x squared, and a line because that'd be y equals mx plus b. We're going to do that as well with this question. So let's talk through these 3 curves, and I'll tell you how I graph them, which is really the only thing I can compare it to. And then I'll show you how to kind of fix it, because I don't know if I would call this cheating. So I'm going to number these. I should dig out my tablet. So just so I don't have to keep writing lots and lots of stuff down, I'm going to number this number 1, number 2, and number 3. Pretty inventive by me. So number 1 is y equals x squared. And I hope you recognize that this is a parabola. More importantly, I hope that you recognize that this is your base parabola, as in the one that isn't transformed in any way. So it goes through 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, etc. as far as you want to go. So what I'm going to do is pretend that my green pen is a pencil, and I'm going to graph the parabola. I guess that'd be sketch. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can barely fit that in. And the other side. Now remember, as you're doing this, if you're following along with me, you should remember that I have crazy smartboard technologies, and you possibly don't. Your technology is an eraser, which you may look at and say, wow, this is not really great technology, but it really is. So here's the y-axis and here's the x-axis before I forget, and that is graph number 1. I know there is more to it than that because I do remember this stuff back here, but let's pay attention to that after. The second piece of information in our list is y equals negative 2x. And I hope you recognize that as a line. I don't need to say straight line, and the reason I don't need to say straight line is because lines are always straight. Curves are always curved. So you don't get a straight line and a curved line. You get a straight line or a curve in class. So this is y equals mx plus b. M is negative 2 over 1. That's here. And b is the dangly number, so it's 0. So I'm going to take my green pen again and go to the y-intercept of 0 and then down 2 over 1, down 2 over 1, down 2 over 1 until I'm bored. So There. And I'm going to draw a freehand line. And remember that I would have a dot here, and I would have a dot here. I'm going to draw a totally illegal freehand line through all of this stuff. Because if it's a line, it shouldn't be freehand. It should be drawn with a ruler. And that was the second one. The third one, the last one in this case, before we hit questions, because the first question is to graph the function. The third one is y equals 2x minus 4. And I hope you recognize that is a line as well. So that's m is positive 2 over 1, and b is negative 4, dangly number. So I'm going to dig out my green pen again, and I'm going to take care of these facts on that same grid. So down 4, and then up 2 over 1, up 2 over 1, up 2 over 1 till I'm bored. Forgot it already. Down 4, up 2 over 1, up 2 over 1, up 2 over 1, which also means down 2 over 1, and totally illegally, not even putting in an effort. There we go. That's the third one. So this is not our picture. And the reason it's not our picture is because this is not a function and you are taking advanced functions, but that's not really the reason. The reason is because I didn't take care of all of this. So this is saying the parabola only counts from x is negative infinity up to x is negative 2, not including negative 2. So I'm going to take out my black pen as opposed to my green pencil, and I'm going to take the parabola and I'm going to outline it until I get to x equals 2, and I went too far. Sorry, x equals negative 2 is right here. And apparently I am not allowed to land on that because it says go from negative infinity to negative 2, not including it. So now I'm going to take out a different color. I'm going to take out red. And red says that the line, the second line that went through 0, 0, goes from negative 2 to positive 2, including both of them. So that means their endpoints are going to be dots. So if I find the second line, here's negative 2, here's 2. If I follow that line, it's here. And I go all the way up to that spot right here, and I put, let's say, dots. Oh, that fills that hole. And then finally, going to dig out blue. This one goes from not quite 2 to infinity. So I probably should have left that little hatch mark at x equals 2. But this third line, you're supposed to use not that, but all the rest of it. Now I get to use my technology to move some stuff out of the way. Like, for instance, that, and that, and that, and that, and that, and all this other green stuff, which you might use an eraser for. And then your job is to take all of what's remaining and make it look way prettier, meaning that should be drawn with a straight line. And this should be drawn with a straight line. And there is the picture of the function. All this stuff was helping you get there. It might have actually been easier for me to use a pencil than it was smartboard technology. So now we have to answer a bunch of questions. In fact, we have to answer 6 questions. So I'm just going to scribble them here and then drag them to the other side. I will use red. So one of the questions is the limit as x approaches -2 from the negative side, a little blurry, of f at x. Another question is the exact same thing, but from the positive side of f at x. And then the overall. So I'm just going to drag them sideways for a second. I guess that would be down. So the difference between this question and the first question on page 102 is that on this question we have to draw the graph, and on the other it was set up for us. And before I forget, this whole picture is your f at x. So question 1, or I guess it was, is -2, x approaches -2 from the left-hand side. So here is x equals -2, left, right. From the left-hand side, we are getting to or almost getting to there, and that is 1, 2, 3, 4 on the y. So this answer is 4. Then if I do the exact same thing from the right, this doesn't matter. This finally collides up here. It doesn't matter if it's a circle or if it's a dot. What matters is that it intends to reach that point, and that point is still 4. And when I take off the left and right indicators, what you need to do is check your previous 2 answers, or at least think through your previous 2 answers. And if it's the same, you steal it. And now I can move all this stuff out of the way and grab the other 3 questions. So, I, etc. I'm going to change colors just for fun. Mix things up for me. Mostly because I change numbers. Now this is not quite the end of everything. I'll explain that in a minute. So before I fit that stuff in, I, IV, that's 4. Five. And overall is 6. So let's refocus our attention on 2. So if you come in from the left, you actually hit that spot right there, which is 1, 2, 3, -4 on the y. Better fill that in before I forget. Right-hand side. This side. Travel in, travel in, travel in. Almost hit that. It's okay for almost in limits. So this is y equals 0. So you don't need the y equals, you just need the 0. It's implied that if I'm giving you the x, you're giving me the y. And then because those two answers don't match, when I ask you overall about 2 instead of left and right, your answer is, there is no answer, as in it does not exist. Now there's one last question here that leads me to a bunch of definitions that are useful for calculus, and that is the function continuous for all values of x? And the question is to explain. And the answer is that this function is mostly continuous, but it's not all continuous. So I will talk about that as soon as I move this out of the way. And I'm going to remind myself that we just finished question B, and now I'm going to do C right here. So I'm going to write it down and then we'll fill in the blanks later. So this function, and it does pass the vertical line test, is continuous everywhere. Hold on a second, I didn't say everywhere. Except x equals 2. So what I need you to know for calculus class is that if you are talking about something being continuous, there is also the opposite, which is discontinuous. And graphs are discontinuous where you lift your pencil. So if I look at this picture and I dig out yellow and I follow along, it's continuous. I'm continuing to do this. And then when I get to here, I have to lift my pencil up, although you can't see it, start back up here and keep going. So that means it is discontinuous in that one position, and that one position is x equals 2. So you can't just say 2, you have to say x equals 2. So the thing I want to add to this is, for those of you who are taking calculus, and for those of you who are going to make it to Jeopardy, these facts are pretty important. So I am going to draw 4 graphs, even though there are only 3 discontinuities. So there's 3 ways that you can typically lift your pencil. So I'm just setting these up. So you've got x and y axis each time, and I'm just going to doodle you some pictures and name what's happening. So the first one is what happened in this picture, and this is called a jump discontinuity. And a jump discontinuity does its magic, gets to a spot, says, meh, I'm going to end there, jumps up to another spot, and keeps going. The other kind of discontinuity is something that we've actually looked at before, but we didn't give it a name as far as discontinuity goes, and that is an infinite discontinuity. And the most famous infinite discontinuity to you guys should be this particular curve from grade 11. And an infinite discontinuity is caused when you have a vertical asymptote. Because if I'm going to go over this, boom, 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 lift my pencil, pen, whatever, continue somewhere else, either below or above. But what matters is I lifted it because this was heading either down to infinity or up to infinity, down to negative infinity. So that's why it's called an infinite discontinuity, and they were always called, they're always caused by vertical asymptotes. Now there's one other discontinuity. I'm just going to get rid of this yellow for a second. There's one other really famous discontinuity as far as being famous in discontinuities goes. And that is the removable discontinuity. So I'm going to draw two pictures of removable discontinuity. And a removable discontinuity does one of two things. It travels along, travels along, travels along, has an empty circle somewhere, and then keeps going. So it's got a hole. The other possibility is that I use the exact same picture. So I'm going to clone that just for fun. Oh, I'm very popular. I like it when you guys find out I'm popular. So there's my picture. It's not exactly positioned this way, but if it's a removable discontinuity, either there is a hole or there is a hole, but in line with the hole on the X, you remove the point and place it somewhere else. So you can either remove it and throw it in the garbage and it never appears anywhere else on the picture, or you can remove it and either stick it below or above your hole, but not in the hole, because then it wouldn't be a discontinuity. So those are your four different types of discontinuities. So the picture we had here was a jump discontinuity. So that is that for this one, and I've gotten smart in the last unit. Number one thing that you could do is you could go to the tutorials that are at www.calculus-help.com, and you can watch Chapter 1, Lesson 1, and Lesson 2, and that might help you out a little bit with the rest of the limits. In the end, the suggested questions are page 103 to 104, number 1 to 3, and 10, and I believe those are questions that look like the original one. However, I've given you a couple of challenge questions here, number 7 and number 8. And number 7 and number 8 are more like this question where I have to draw it and then talk about it. So it's a combination of drawing and then doing your limit work. So that is if you're working out of the workbook, which is also on the Google Classroom. So the end of limits graphically. We get to do algebraic limits next.